Welcome to day 3. We've covered the why in the earlier sessions, why the perimeter fails, why hybrid work breaks traditional controls. Today we go deeper into the Zero Trust Exchange itself. By the end of this session, you should be able to explain what the ZTE is architecturally, how it processes every connection, what its 4 security methodologies are, and why it's built as a unified platform rather than 3 separate tools. What is the Zero Trust Exchange? At its core, the ZTE has 3 components. First, global service edges. These are the enforcement points distributed around the world. Every connection is terminated here, inspected, and forwarded. Anycast routing means users automatically hit the nearest edge without any manual configuration. Second, the central policy engine. This is the brain. It evaluates every single connection against identity, device posture, location, and application sensitivity. It's the same engine that drives decisions in ZIA and ZPA. Third, the unified control plane. This is where you, as an administrator, actually work. Configuration, identity integration through your IDP via SAML and SCM, analytics, logging, all managed centrally. The critical thing to internalize from this slide: ZIA, ZPA, and ZDX are not 3 separate products that happen to be sold together. They are 3 services built on the same identity, the same policy framework, and the same logging infrastructure. That's what makes it a fabric. Core principles. 3 foundational principles, and the exam will test all 3. Principle 1. Identity and context-based trust. Trust is never, ever based on network location. Every connection is evaluated against who the user is, from your IDP via SML or SCM, what device they're on, from client connector pulling OS version, EDR status, device posture, where they're connecting from, and how sensitive the requested resource is. A concrete example: your finance team can access the SaaS CRM, but only from corporate managed devices with current EDR agents. Contractors can access a subset of private apps, but only through browser-based access. All of that is policy-driven, not network-driven. Principle 2. Application segmentation with zero implicit trust. In the ZTE, segmentation happens at the application level using app segments in ZPA, not at the network level using VLANs. And zero implicit trust means even a user sitting on the corporate LAN has their traffic evaluated by ZIA and ZPA. Being inside grants nothing. Principle 3. Secure connectivity over any network. Home Wi-Fi, corporate office, airport hotspot, all treated identically. Security is enforced at the service edge, not the transport network. How the ZTE processes every connection. This is the proxy model in action, and it's critical for the exam. Step 1. A user requests a resource. Their traffic is steered to the nearest service edge via client connector, PAC file, or a GRE/IPsec tunnel from a branch office. The connection is immediately treated as untrusted. Step 2. The ZTE gathers context, identity from the IDP, device posture from client connector, location, network type, and the sensitivity of what's being requested. Step 3. The policy engine evaluates all of that. The decision is allow, block, isolate, or step-up authentication. Not a single connection passes without this evaluation. Step 4. If allowed, the traffic is decrypted and inspected inline. Threat detection, DLP scanning, app protection for private apps. Threats are blocked here before they reach the destination. Step 5. The ZTE establishes a brand new, separate connection to the destination. Read that again. A separate connection. The user's session ends at the service edge. The ZTE makes a new session to the destination. Users and applications never communicate directly. The proxy is always between them. This is the architectural detail that makes Zero Trust real. For security methodologies, the 4 methodologies map directly to phases of an attack lifecycle, and each one has concrete configuration tasks. M1. Minimize attack surface. This is pre-attack. ZPA app connectors make private apps completely invisible. No public IP, no inbound firewall rules. External scanners cannot find what they cannot see. The config task is app connector placement and app segment definitions in ZPA. M2. Prevent compromise via inspection. This is the initial access phase. ZIA inspects everything outbound inline. Advanced threat protection, cloud sandbox for unknown files, DNS security. For private apps, ZPA app protection handles OWASP Top 10, SQL injection, cross-site scripting, and others. Config task, TLS decryption policy, and ADP rules in ZIA. M3. Eliminate lateral movement. This is post-breach. ZPA creates user-to-app connections, never user-to-network. A compromised device cannot scan internal hosts or pivot. The blast radius is structurally capped. Config task, app segment access policies in ZPA. M4. Stop data loss, data stage. ZA inline DLP inspects every upload, post, and outbound transaction for PII, financial data, source code. SaaS security, the CSB function, scans SaaS tenants out of band for sensitive content and risky sharing. Config task, DLP policies, dictionaries, and actions in ZIA. App segmentation versus VLANs. This comparison comes up directly in ZDTA scenario questions, so spend time with it. VLANs carve the network into subnets. If you're on a subnet, you can reach any host on that subnet. Access is determined by which VLAN you're on, which is tied to your physical or virtual network location, not your identity. And if an attacker compromises any host on your VLAN, they can see and reach everything else there. App segments in ZPA work completely differently. Access is bound to specific FQDNs, IPs, and ports, not network segments. Users can see only the applications their policy allows. Even if two applications share the same underlying physical network, a user authorized for app A cannot see or reach app B. And because it's identity-driven, moving an app to the cloud just means updating the app segment, not redesigning the network. The key ZPA answer to memorize. VLANs prevent network-level segmentation. ZPA app segments prevent application-level access and make lateral movement structurally impossible. Traffic flows and connectivity methods. This slide is your map of how traffic actually gets to the ZTE and what happens inside it. On the inbound side, how traffic reaches ZTE, you have four methods. Zscaler Client Connector is the primary agent deployed on endpoints. It steers traffic automatically to the nearest edge and collects device posture. Pack files redirect browser traffic for environments not using the agent. GRE or IPsec tunnels from branch offices and data centers forward all traffic without needing an agent on individual devices. And app connectors, inside your private environments, establish outbound TLS to ZTE. This is the ZPA model, inside out, no public IP. On the outbound side, how traffic is handled inside ZTE, there are three main paths. User to internet or SaaS goes through ZIA. TLS decryption, threat inspection, DLP, CSB, then forwarded to the destination. User to private app goes through ZPA. Identity evaluated, app segment policy checked, connection brokered via app connector. And cloud workloads use cloud connectors to reach the internet securely through ZIA policies. Knowing these flows is essential for the platform management and integration and optimization exam domains. 3 strategic benefits. 3 benefits that directly address the ZDTA exam's emphasis on practical outcomes. First, simplified cloud-first networking. The ZTE replaces complex MPLS hub-and-spoke designs with lightweight tunnels to service edges. Client Connector automatically selects the optimal edge, no routing design required. New branches onboard through configuration, not hardware. When a new SaaS app gets adopted, you update a ZIA policy. You don't touch the network. For M&A, you can give acquired users secure access in days. Second, unified security stack. ZIA alone is SWG plus cloud firewall plus DNS security plus CSB plus DLP. ZPA adds ZTNA and app protection. ZDX adds digital experience monitoring. All of them share the same policy framework, the same identity integration, and the same logging infrastructure. Log stream via NSS for ZIA and LSS for ZPA directly to your SIEM or SOAR. Third, scalable multi-tenant architecture. Logically isolated per customer, but shared elastic capacity. Anycast routing sends users to the nearest edge. Zscaler handles upgrades, patches, and capacity scaling. You never manage hardware life cycles. When 50,000 users suddenly went remote, organizations on ZTE scaled immediately. Organizations on VPN concentrators did not. ZDTA exam cheat sheet. Keep this slide handy. These 10 Q&A pairs cover the most commonly tested day one concepts. Let me call out a few that people trip over. App segments replace VLANs. Not just conceptually, but architecturally. That answer needs to be fast and precise. App connectors work via outbound TLS. No public IP, no inbound rule. That's the mechanism behind zero attack surface. NSS is for ZIA logs. LSS is for ZPA logs. The exam will distinguish between them. And Anycast routing is the mechanism that gives you both low latency and high availability in the service edge design. Not a configuration you make, but an architectural feature you need to explain. Key takeaways. 6 things to close on. The ZTE is a proxy, always between users and apps, a new connection made to the destination on your behalf. 3 pillars: identity, context, and segmentation. Network location grants nothing. App segments replace VLANs. Segmentation at the app level, lateral movement structurally eliminated. The 4 methodologies map to the attack lifecycle. Minimize surface, prevent compromise, eliminate lateral movement, stop data loss. Each one has config tasks in ZIA or ZPA. App connectors are inside out. Outbound TLS only, no public IPs. Apps are completely invisible to the internet. And ZTE is a unified platform. ZIA, ZPA, and ZDX share one identity system, one policy engine, and one logging stream. If you can explain all 6 of these in your own words, you're solid for day 3.